Hello, my name is Michal Polic and I'm gonna show you how to solve the test number 1. The first task is to find the coordinate system beta sigma prime, which is composed of O prime and beta prime. And we know x prime in beta prime and y prime in beta prime. So we also can read from figure what is x in beta and y in beta. And use the standard transformation function. X in beta equals transformation from beta prime to beta times x in beta prime plus O prime in beta. And the same holds for y, therefore we can write both equations as 1, where x and y in beta will be on the left side, then there will be a transformation from which we don't know the beta 1 prime. This transformation matrix transform the points x and y in beta prime, and we also have to add some origin O prime in beta. If we multiply all these equations, we will get 4 equations in 4 unknowns, where the first 2 equations has 2 unknowns and the second 2 equations has second 2 unknowns. Therefore it can be solved separately. Note that I suppress the beta in O prime for brevity. This way we get the O prime in beta equals 0 and 0.5. Note that because beta is a standard coordinate system, we can suppress it and write b2 prime as 1 1 without the beta as a lower index, and the same for b1 prime, which is 2 minus 1. So to fulfill the first subtask, we have to draw it in the figure. So we will draw first the O prime, then from O prime we will draw the beta 2 prime, which is just shift about O prime, and the vector b1 prime, which is 2 times beta 1 and minus 1 times beta 2. We already know what is beta prime in beta, which is C subtask. So it is 2 minus 1 1 1 matrix, and the B subtask is to compute the inversion of this. We can compute the inversion by adjugate matrix and determinant. So it's 1 over determinant times the adjugate matrix, which is 1/3 times 1 1 minus 1 2. The second task is to find all solution of the system of linear equations. We can see by Gauss elimination that this matrix A has rank 2. For example, if we multiply the first row by -1 and add it to the third row, we will see that we will have 0 minus 1 minus 2, and the second and third row will be linear dependent. So we can write x as x homogeneous plus x particular. X homogeneous part means that a x h equals 0. If we multiply the first 2 rows times x, we will have 2 equations with 3 unknowns. Therefore we can substitute one random variable, one real number, for example t, for xh3, and then express xh1 as t and xh2 as -2 times t. The particular solution is obvious from the assignment. For example, it is 1 1 1. So the final result is that x1 equals t plus 1, x2 equals minus 2 times t plus 1, and x3 equals t, where t is some real number. The third task is to find a projection of three-dimensional point by projection matrix. So we know lambda times u1, u2, and 1 equals p times this point, which is 1, 2, 2, and we have to scale it to have the third coordinate equals 1. Therefore, u is equal 0.51. The next task, fourth, is to find focal length from projection matrix. We have f times a3 vector transpose equals r3 transpose, and focal length is 1 over square root of 2. In the last fifth task, we have some bases. Let's call it alpha and center C as a sigma coordinate system. So alpha 1 is 2 times beta 1, alpha 2 is u, and alpha 3 is b3 minus u. We are looking for coordinates of vector x in our alpha coordinate system. We see that x is from C, therefore we define C as origin for this coordinate system. If we look at the figure, we can see that 1 times alpha 3 plus 2 times alpha 2 gives us the vector x in our alpha coordinate system. Therefore, the x in alpha will be 0, 2, 1 vector. And that's it.